Welcome to The Explainer. Today, we're diving into something pretty amazing. We're going to explore how a truly revolutionary technology is tackling one of humanity's oldest and most fundamental challenges, how we grow our food.
You know, the world's food systems are under some serious pressure. We need to produce more food, but we have to do it while reducing our environmental footprint. The good news? A new technological revolution is taking root. It's called Agriculture 4.0, and it's transforming farming from an art of tradition into a hard science of data. Okay, so here's how we're going to break it all down. First, we'll look at the big challenge we're facing. Then, we'll get into the core idea of the digital twin. After that, we'll see the tech that actually makes it all possible, check out the real-world results, and finally, take a peek into the future of the field.
Right, so we're in the middle of this massive shift. For centuries, farming has relied on experience, intuition, and, well, the calendar. But that's all changing. We're moving into what's called Agriculture 4.0, or precision agriculture. And the goal is beautifully simple. Use data to give crops exactly what they need, exactly where they need it, and exactly when they need it. No more, no less.
Now, the solution here might sound like something straight out of a sci-fi movie, but its origins are actually rooted in one of the most high-stakes environments you can possibly imagine, the Apollo space missions. The big idea is to create a perfect virtual copy of the farm. So, picture this. It's the 1960s. The Apollo 13 mission is in deep, deep trouble. How did NASA solve it? They had identical, physical replicas, twins, of the spacecraft right here on the ground. They used these twins to test solutions in real time and, well, bring those astronauts home safely. It was a brilliant idea that, over decades, evolved from physical models to the super sophisticated, data-driven virtual models we're seeing today. So, what is a digital twin when we're talking about a farm? It's essentially a living, breathing digital copy of something physical. That could be an entire crop field, a single apple tree, a tractor, or even one specific cow. And the key word here is living. It's not a static blueprint. It's constantly being fed real-time data from the physical world. And this right here, this is the secret sauce. This is what makes a digital twin a total game changer. A traditional simulation is like a one-way street. You plug in some data, and it spits out a what-if scenario. But a true digital twin has a bidirectional or two-way connection. Data flows from the real farm to the virtual twin, and this is the cool part. The twin can then send commands back to automate machinery in the real world. It's a constant conversation between what's real and what's virtual. So how does this all actually work? I mean, how do you build a virtual farm? Well, it's not about one single gadget. It's more like a symphony of cutting-edge tech all working together in perfect harmony. It all boils down to this four-step loop. First, you sense the real world using things like sensors and drones. Then you process that data, some of it instantly, right there on the farm for speed, and the rest gets sent to the cloud for a deeper look. Next, AI models analyze all that data to find patterns you'd never see on your own. And finally, the system acts on those insights to automate and optimize the farm. Let's look at the toolkit. Think of the thousands of IoT sensors as the farm's nervous system, constantly feeling the soil moisture or nutrient levels. Drones are the eyes in the sky, using special cameras that can spot crop stress way before any human could. Edge and cloud computing act as a powerful, distributed brain to make sense of it all. But the real intelligence? That comes from AI, which takes all that raw data and turns it into shockingly accurate predictions. Okay, so this isn't just some cool tech theory, right? It's happening now, on the ground, and delivering measurable, game-changing results. In Agriculture 4.0, data isn't just information. You could say it's the new fertilizer, making every single part of the farm better. And these numbers really tell the story. By watering and fertilizing only the specific plants that need it, we're seeing incredible efficiency. I mean, a 30% drop in water use for a large farm, that's not just a small saving. That's millions of gallons a year. Slashing fertilizer use protects our waterways, and cutting pest damage means more of the food we grow actually makes it to our plates. The predictive power is just staggering. One study, using a machine learning model, was able to predict how much a field would yield with nearly 99% accuracy. Can you imagine what that means for a farmer? It takes so much of the guesswork out of planning, logistics, and sales. It fundamentally changes the economics of farming. And hey, it's not just for plants. The same idea applies to animals. By creating an individual digital twin for every single cow, using wearable sensors, farmers can monitor the health of their whole herd in real time. The system can flag subtle changes in behavior that signal an animal is getting sick, often days before a person would even notice.
And it's not just us saying this. As industry leaders like Daniel Rooney point out, the real magic here isn't just making a map. It's about building a living, interactive model that truly mirrors what's happening on the ground second by second.
So if this is all so amazing, why doesn't every single farm on the planet have a digital twin already? Well, as with any huge leap forward, there are definitely some big hurdles to overcome before this technology goes truly global.
The main roadblocks right now are pretty straightforward. First, the high upfront cost for all the sensors, drones, and software. Then there's connectivity. A lot of rural areas just don't have reliable, high-speed internet, which is a big problem for real-time data. And finally, there's the headache of making sure all the different gadgets and systems from different companies can actually talk to each other. But the future here is incredibly exciting. The arrival of 6G networks will mean basically zero lag time, making it possible for swarms of autonomous robots to work together in the fields. We're seeing the rise of digital breeding, using these virtual models to design new types of plants that are perfect for a changing climate. And soon, we might even see federated twins, where whole regions of farms can share data anonymously to learn and adapt at a massive scale. And all of this leaves us with a final, pretty mind-blowing thought. We are rapidly moving from a world where we just monitor and react to our environment to one where we can actively simulate and, well, design its future. The farm of tomorrow isn't just smart. It's a living, learning ecosystem, being designed one data point at a time,